Welcome everyone to an after work facepalm edition. Yesterday on the other More Life YouTube channel I discussed that I found this x86 Linux kernel still not booting as expected on transmitter Crusoe or AMD x86 or early VRC3. I knew this always, but I pointed out that was a rather political discussion of not supporting this intentionally, like 586, but with basically full x86 instruction set, compare exchange 8, CX8, cmove, conditional move, timestamp counter. The only thing basically missing was NOP, long NOP variant, and that was basically, I showed the discussions here. I was aware of that, I found it silly back in the day, and so on. You probably want to watch this video, I will not repeat all of this. But what I find even more crazy is after the live stream, so I found the whole stuff of, it's just because of this tiny long knob instruction that not supporting it. We don't make it a 686, right? Basically preventing a full x86 Linux distribution to have some 10, 20, 50, or even at times 100 doubling the performance percent depending on your code with conditional move and so on, right? Basically hindering this alternative non-mainstream clone manufacturers. But what I found after the video at night, when I finished this integrating improvements into two, I was shocked and speechless when I found that in 2008 already, after all this discussion, right here, all this discussion, someone with a patch like promoting that to x86, some people in yeah, some people in there, but it's not really x86, yada yada, details in the previous video, right? They fully disabled that. Since 2008, it's like completely disabled NOPL on 32-bit. So even since then, at that time, of course, x86 already the ship sailed, not state of the art anymore. But after years of discussion and preventing the competition, of like at Intel and stuff developers, it turns out Microsoft's virtual PC is so broken it can't even really fail. Like yeah, Microsoft stuff is buggy. Why don't we use Windows because bugs? It's absolutely mind-blowing. So first they argue for years, no, we can't give you the full x86 performance because it's bloody no operation, a long do nothing sequence. But then some Microsoft Virtual PC, which literally nobody noticed, and like if Microsoft Virtual PC is so effing broken, just patch this bloody software, right? So this transmitter Crusoe with early VRC3 and with National Semiconductor, later AMD x86, they couldn't do it, but when Microsoft has a bloody virtual PC virtualizer that nobody effing uses and they could fix in software, then they fully disable it. For all of, I did not even know, like I knew a lot of this background, but I didn't even know that since 2008 we don't even have this optimized long knob sequence. Absolutely mind-blowing. This code is like that still to the day. Linux 682 as released of today in there. So here previously they had tried to detect that, and it's like this leaves the infrastructure in place but disables this. They remove Itanium because it's a complex mess. Like, excuse me, Itanium is far from the complex mess that is in there. I should not say that too loud because otherwise they will simply delete this. I did, of course, what I usually do when the Linux kernel developers for decades produce buggy, half-working, and at the end disabled code. I just restore it. So as of today, T2 not only is the only Linux distribution that automatically promotes such full-featured 586 to 686 processors for a whopping performance improvement, so that you can run T2's highly optimized high-performance x86 Linux on your vintage and retro silicon. I also restored this long knob detection because we can, right? Red Hat can't do it, SUSE can't do it, certainly not Oracle, the broken Linux can do it. Certainly Microsoft with their Linux distribution is not interested because their virtual PC was already broken decades ago. Restoring this was not a clean revert because in the meantime later they changed not passing here this struct CPU info stuff, so I had to tweak that a little bit of using the boot CPU data, so that did not revert. And also, basically, they make this, as you see here, maybe in one of the commits. No, so this commit disables this fully, but later they actually changed that to completely disable. Later they actually changed this, here with this commit. They actually changed this to, on 32-bit, you don't get it, like the only architecture where it would have made some sense, like 32-bit x86, yeah, we previously for decades prevented high performance on AMD Geode, LX and Transmeter Crusoe, but now you only get it for 64-bit Linux. It's like due, basically making exporting NOPL in proc CPU data static for 32 versus 64-bit. I of course now restored it right. I do this, what I usually do here, I did the right thing. So T2 increasingly the bug-free high performance and just generally sane, minimal and simple, yet bug-fixed and fully working Linux distribution. Restoring this detection here, because you know what, Microsoft, F you and your virtual PC, I couldn't care less if you still run virtual PC, switch to QEMU. If you have broken virtualizers that cannot fail. Although I would say this detection code is a little bit nah, they run here this NOPL, which may or may not fail. I mean, on real hardware it should fail, on buggy Microsoft software virtualization it probably does not fail reliably. They use here some ASM, they use here some section fix up AX for if this is faulting, change AX. So this is, maybe it doesn't work reliably because they quirk it here so stupidly. I would think otherwise, whatever, which I don't care. I mean, I would not detect it like this. This is somehow their Linux kernel style of using this automatically fix up AX register section, but they do their thing. We just fix what we got. The history is, however, curious. I later found a website where someone collected even more. Where did I do this? Did I close this here? Here. I linked this on yesterday's YouTube video already. If we want to go over here, I forgot even some details and I didn't even know all the details. So basically this instruction that they argued so much in the 2000s, 15 years ago, is actually, so was introduced with the Pentium Pro, we all know that, but what I also didn't know, so nobody like released the Pentium Pro, but nobody knew that, right? Documenting the entire instruction set, however, Christian Ludlow had created a map of 2-byte x86 opcodes. This confirmed into the documentation, but included a few unknown opcodes, like those here, and so it was initially not even documented, which is also why clone manufacturers did not necessarily implement it then, because nobody knew that they were there. And then just later, it was discovered by people scanning through all the opcodes and see what else is there, like previously undocumented save all instructions of internal debugging use and not really meant for production use. So were determined to be, like, for example, later, 1997, those opcodes were actually determined to be Pentium 2, sys enter and sys exit, which despite Intel only documenting this later in 1999, so much to why did this alternative x86 clones not implement this? Because it wasn't documented, nobody was using it, right? Not even operating systems. Sys enter, sys exit, by the way, alternative, like previously we did this with soft interrupts, in Linux interrupt 80 hex. In other operating systems, potentially others. And so this enter and this exit were dedicated instructions of not using software interrupt for system calls, but instead dedicated potentially higher performance instructions. And hilariously enough, the Geode LX800 identifies as a Pentium, but supports this enter and this exit instructions introduced with the Pentium Pro and finally made useful with the Pentium 2. Then, however, they undocumented 2-byte opcodes were hinting knobs, documented that in 1998 by other people, not even by Intel, not even Intel saying, hey, these are long knob sequences, like other people fiddling around there's like, yeah, what, poking the CPU, like what you're doing there. Where's even my, it's like, what you're doing there, what's up there. So with pref and maps the prefetch and instructions for hinting to prefetch data. Later in 2003 only, Christian Ludlow clarified in an email undocumented hint knob that these hinting knobs were declared by Intel in a patent application of all things. So much too, why did clone manufacturers not implement this? Like, yeah, it's like a nice patent application you got there for method of modifying an instruction set. Just like modifying of like method of adding to instructions. Method of architecture modification, including step to identifying, defining an instruction set for current generation processor, like strange patent applications, always strange text of like, nothing really new, we make it look like we reinvented the world and the wheel and stuff, like basically not much new. But here's also like BSwap, I probably should read this amazing patent. And somewhere there's here like hintable instructions which perform no operation. Each of those hintable knobs has a unique opcode for like hinting additional things, have no attached semantics of like basically documenting, hey, this instruction doesn't really do much but might have some hints, like this branch will be taken, this memory might be accessed, like you could start fetching some memory because we so need it. It's like, that's why we need software patents, right? Amazing stuff. For innovation or preventing innovation, but don't tell that language patent lawyers to load. So clarified that idea behind those patents from readings that they encode a program written in another ISR as a series of codes that are run as a knob on an older machine, and a new ISR means some special stuff, hinting stuff, right? The birth of the multi-byte opcode. So in 2006, Intel released, then later, like basically a decade later, Intel released the updated IA32 manual only, so much too, that was also the heated discussions of not allowing certain clones that didn't implement this. Nobody knew that, but hey, how did you not know about the secret hidden, undocumented but patented instructions in your code morphing software 10 years earlier? Multi-byte opcodes, long knobs. This could be 2 to 9 bytes, as I mentioned. I believe they're even I'm pretty sure they are sequences as long as 15 bytes. For knob, I said this for alternative patching, right? Pretty useful instructions, aligning code and data, just as I mentioned yesterday in the other video. You probably want to go watch this and subscribe to the additional more code therapy channel. The only thing about this instruction is that they marked available in Pentium Pro and newer machines, despite being documented like 1 decade later. Thanks, Intel. Maybe in the future, can you disclose all your secret hinting patented instructions? Someone pointed out that on the Intel forum, here multi-boot knob in more detail, made official, they had tested and verified that the feature, and even pointed out that it works on AMD processors despite this instructions not being documented anywhere. So maybe AMD, like either AMD knew from shared patent stuff or patent sharing agreements and deals, or they simply scanned all the instructions like other open source people did and discovered with a debugger, the instruction doesn't do much, let's better implement it as a no operation as well, whatever the case might be. If you worked for AMD in this time, and so leave it in the comments below. Someone pointed this out in the Intel forum, right, we were there. They asked a few hard-hitting questions to Intel. Why was this opcode secret? Why does it work on AMD? Like maybe patent sharing, or AMD just did a very good job scanning the whole opcode range just to make sure the CPUs are maximum compatible. Why does AMD recommend? So why does AMD recommend another opcode sequence for multi-byte? So like Intel has patented like, hey, look, let's use this special, like, okay, actually not. So they patented it, kept it basically somewhat secret though, and told nobody. In a moment we will see why, but the story is absolutely insane, to be honest. But AMD recommends something else, probably for good reason, because turns out you don't need Intel's annoying patent there. You can also use prefix, or repeated prefix, right? XX is the, I believe 32 prefix override or so. So it's basically reusing the x86 hex prefix of 32-bit like multiple times. Like you can do that like a lot of times. It's like, yeah, I really want 32-bit prefix override. Like, yes, do more of those. It's like, and then no operation. It's like, okay, fine. It's also a patent avoiding sequence. So Intel got back to them with, this information is Intel confidential and would require an NDA. Like in 2006, 10 years later, We patented it, there's a patent application, but to tell you more, it's so top secret, this no operation is so top secret. Do you even have an NDA with us? It's like do why I hate patents if you couldn't tell. Crazy enough, so going just back, guess AMD recommended the 6690 opcode series because CPU optimized it and worked on all the machines, while the Intel and their solution seems to recycle some trash. Because turns out 2007, the Mantec of all wrote a blog post, x86 fetch decode anomalies, showing that Intel's hinting opcodes, like because they write hinting, right? They do not write long, they the whole time wrote hinting. So it's not even a true to nature just an operation. No, it does some hinting. Assigned to those multi-byte recycling, because so, recycling old trash, right? Turns out they actually will attempt to fetch memory. What? Today, no, actually last night I learned, not till I learned, like last night I learned the long no operation battle that was fought on Linux kernel about not promoting certain CPUs that didn't have this cursed, patented, secretly hidden, and actually hinting long no operation actually will fetch memory. Like, dude, what? Are you effing kidding me? And for this garbage, recycled trash no operation, we made such a fuss, changed it multiple times, broke it multiple times, and at the end disabled it due to virtual PC of all things. Are you kidding me? On what drugs have you all been the whole time? Like kids, drugs are not good for you. I never did drugs. I can't recommend drugs. Maybe I get so much done because I don't do drugs. Yeah, probably go read this 2007 Semantic blog post if you still find it somewhere archived. And even freaking page fault if you instructed to. This isn't a problem in practice, but it gives some more evidence that this opcode actually isn't strictly a NOP. Linux Fallout 2006, as I had added yesterday, add no NOP memory for that, was committed to the GNU assembler, support for NOPL and NOPW assembly instructions. Then it turned out 2007 x86 multi-byte string, a single instruction NOP was committed to Linux. This added a set of P6 NOPs. A decade later, right? A decade later, we optimized for Pentium Pro. They used multi-byte, like secret, so secret you need an NDA for those. Used them for x86 and newer, and that is where all the fuss then started. And turned out, as usual, the only constant is change and regressions, right? Which type of knobs to use were decided at runtime. Running on a 686 kernel on a 586 machine would not cause any issues with that. However, it would, I mean, this is not strictly true because running a 686 kernel would not boot as seen yesterday, right? They checked the features, like, yeah, running, I mean, I'm not sure what the summary is because, yeah. Strangely, 64 systems, the knobs were only used if your vendor was Intel. Like, what? That also changed in the meantime? It's like, whatever. However, as usual, only constant change and regressions, of course, it caused regressions. Oops, sorry, accidentally clicked there. In 2008 Debian, bugs, 2624 fails to boot on Microsoft Virtual PC 2007. It's like, due. And x86 build uses long knobs unsupported on transmitter crew. So I told you so, immediately crash on boot were reported. After a lot of discussions, as outlined yesterday and summarized today, the following CPUs were reported to not support multi-byte knobs: VIA C3, EMEA, Transmitter Crusoe TM580, Microsoft Virtual PC 2007, QEMU, AMD Geode LX800, of which we have half of them here. Interestingly enough, the TM5800 reports its CPU ID family as 5, like the LX800 does, but for the 58 kernel promoted status to x86, as I outlined earlier, which was also reverted, and like there are bugs, regressions. It's like Zelix reports this family to 5, shouldn't have failed due to the patch, looked or whatever. So in parallel, x86 kernel wouldn't boot under Virtual PC was reported on the Linux kernel mailing list. This had a bit of more focused discussion about how to address the problem. Summarize the discussion: the GNU assembler shouldn't generate multi-byte knobs at all for x86 CPUs. which also then, as I said yesterday, people disagreed. It was like, no, it's x86, let's generate, like it wasn't documented for a decade, but let's generate it anyway. Requires family greater equal 6 for using P6 NOPs, yay. Don't use P6 at all. Compiling, it's like, yeah, the only constants change and regressions and gazillions config options. Why do we have 16,000 config options? Because each crazy buggy stuff needs to be config options. This decided transmitter CPUs, crucial CPUs weren't x86 due to this bloody, like yesterday, like it doesn't have one obscure, not even documented, not even truly no operation, but hinting no operation. Let's not make the 6x like give you less performance for real hardware because virtual PC crashes. It's like, what? You had one job? Dude, this is also cursed. And this is on top of the complexity that x86 already is, right? I mean, not like x86 would be complex enough, like no. Secret, hidden, hinting, patented, not truly implemented, and cursed. Instructions. At the end, completely disabling no operation long NOPL on 32-bit builds. All this fuss and breaking to the day, not having x86, 686 kernel on transmitter, yes, in the meantime, very vintage and retro, but hey, 2008, it wasn't that vintage and retro. Like 2006, it was still like not even that old and still somewhat usable. I mean, it's today usable as a thin client or vintage and retro fun. And significantly faster if you run a true full x686 userland. Instead of adding multi-byte knobs on 686 and beta machines during the kernel build, the plan was only use multi-byte knobs at runtime based on whether the CPU, yada yada. Unfortunately, developers found that GNU assembler would add multi-byte knobs all the time for x86 and virtual PC would freeze during detection of multi-byte knob support. In the end, they just threw their arms up and said, nah, no multi-byte ops. However, they did not restore. Even with this, at the end, you know what? We just disable it. Like you only get it for 64-bit. It's like, dude, because of one broken Microsoft product. It's like, why not tell Microsoft virtual PC users? It's like, sure, the hardware doesn't agree the most. In my opinion, F this patented hinting cursed long knob thing from Intel and give proud owners of transmitter code morphing Crusoe and Geo LX one freaking laptop per child, right? We wanted to give each developing child a $100 laptop that shipped with a Z. Like why was it not even fixed for the one freaking laptop per child to have at least those poor kids have some more performant OLPC X01. Anyway, that is basically most of this. There is more assembler confusion by 2008, midst of the kernel, Fallout. It's like all of this for one, like all of this history. I knew only half of the history. I literally learned the other half of the history, literally Googling this cursed stuff yesterday, bringing it to you for your complex x86 knowledge today. Compiling code, and you don't specify CPU family to support which CPU to optimize. The kernel developers found that the GNU assembler wouldn't add multi-byte knobs if you targeted x86 family. Instead, it only added them if you targeted x86. What? CPU? Not even sure what. Not even sure what they mean. Maybe they mean Pentium Pro versus x86, or they mean Tune versus whatever. Yeah, like different. Like yeah, it didn't work quite right. The bug reporter believed the bug reporter believed multi-byte knobs are not part of the the bug reporter believed it wasn't documented by Intel. It was not implemented by some CPUs, so don't use it, right? Like, if you would have from the beginning made a reasonable decision of like it wasn't documented, not implemented by everyone, just don't use it. Use it if you have an Intel CPU or newer or whatnot. Optimizing for the 686 is adding Pentium Pro only instructions. 686 architecture should not emit multi-byte knobs. The GNU assembler developers, some probably from Intel, at least some usually were as far as I remember, multi-byte knobs are indeed part, like as yesterday's code therapy, political, misguided discussions. It's like, no, it isn't. Like, if not all other x86, 686 CPUs implemented, it's not part of the generic 6. It's so simple. And even if it would be part, like it wasn't, it was top secret and you needed an NDA. And Intel documented it a decade later. And even if it were, but not implemented by some clone manufacturers, I would still argue it's a pointless feature that can even be misused to cause a page fault. And even if it were part, which it wasn't, it should anyway, like it is today, made a Pentium Pro and later specific option. Optimizing for 686 CPU is using 686 instructions. Developers should build against 586. It's like, and there you see disagreements, and like instead of finding, I mean, sure, it is a solution. It's just a conveniently performance hindering solution for your competitors, right? Absolutely crazy stuff. glibc, Fallout, passing MTune x86 to assembler when compiling. x686 was committed to glibc. This told the GNU assembler, the buggy GNU assembler, to optimize for x86, Pentium Pro, like not Pentium Pro, like taking it as Pentium Pro, and as mentioned in the previous section, used multi-byte knobs. A month later, Arch Linux bug updated glibc on VIA C3 Nehemiah, make system unusable. Fedora bug. It's like the only constant is change and regressions, right? And if you ship buggy CPUs like Intel usually did, and then glibc not compatible with AMD GeoLX, one laptop per child, right? And countless of very popular PC engine or whatnot, and many people use this for routers, right? It was a very popular, I mean, it was a very popular embedded CPU in general, plus OLPC and routers, PC engines or whatnot. glibc, being a core component of the GNU system, made update, completely crashed people's machines. Oops. Unlike the Linux and GNU assembler discussions, Arch Linux and Fedora discussions were from the perspective of people building and packaging software like ourselves. Finding out what was broken was a little tricky as usual, right? Spending hours debugging stuff. What GNU assembler, adding NOPL to the code. glibc, tuning for x686. What Linux distributions building for x686 for not Pentium Pro CPUs. Things were a little tricky for Fedora. Explicitly supports AMD GeoLX 800 and was used in millions of laptops and one laptop per child project, while it didn't advertise 686. It run those binaries otherwise, right, with twice the performance over 486 binaries. Yeah, around this time the GNU assembler committed don't generate. After all, right, years later and after heated political discussions, they finally fixed the GNU assembler don't generate multi-byte knobs for 686. The only reasonable choice. Finally done. But yeah, what's not tested is broken, right? And that is why people ridicule me here for taking out vintage and retro. Not only do I want to work on everything, it's also fun, a hobby, kind of fulfilling if you ain't wasting hours broken stuff. And what you're not testing is broken, right? Just today I found taking out my VIA CHA001 prototype, SHA 2 architecture, and found by pure chance that we need more network physical modules to use more network booted NICs there, which I would other find only in the next embedded or data center project, right? And that's why we test here. We test because what's not tested is broken, especially with all those random changes. Like let's generate some obscure knobs that nobody documented in a decade. Like, what could possibly go wrong? Strange enough, the 586 MDK 6.2 CPU was marked as supporting multi-byte knobs, which was fixed in the 2000. Like, strangely enough, they marked the 586 CPU to support them, although it didn't. Yeah, GNU quality, we have shouted this out a couple of times here. Kernel emulation in 2010, as I mentioned yesterday, was proposed to patch the geo long knob emulation. This patch would trap this unknown instruction and emulate it. Arguments for the patch: distributions aren't going to care long term. Proprietary software isn't easily fixable. Similar patch used to CMove on 586. Arguments against: NOP is not supposed to spend thousands of CPU cycles. As I mentioned yesterday, right? I agree. Emulating this in kernel is pointless. Like, really don't use it. Like, you don't want a 2 orders of magnitude performance marginality just because there are some random, like you want to know if there is a stray random long knob, you want to know and not use it, because otherwise it just hurts performance badly. With the new assembler fixed distributions can avoid that, as T2 always did. I patched that already 15 years ago because that was a bug. And a bit later, but again, so all of the stuff was not reverted. It remains disabled until this day. And very little was learned of this pointless political fake discussion. A bit later, someone started a mailing list thread promoting Crusoe and Geo x86, which yesterday I only found, which is not in the Linux kernel. So despite this being disabled, there is basically no gain of disabling. Like who in their right mind disables a whole feature that they discussed for years and produced countless bugs? They disabled this just because of Microsoft Virtual PC. It's like, I have no words. So yeah, if x86 T2 releases in the future, because it is now the only Linux distribution that finally promotes Z CPUs to 686 and implements, actually reactivates the long discussed performance optimization as of today works in T2 again, probably will potentially never in Linux kernel again proper. I only hope they don't delete this whole infrastructure, because if they delete the whole NOPL patch alternative infrastructure, I don't think I want to support this long term, but as long as they hopefully don't tell them to load. Anyway, we are here to fix all most obscure bugs we find and make sure to deliver the highest performance for your SGI MIPS, PowerPC, PS3, Power, Macintoshes, or even vintage and retro x86 clones or epic thread-ripping latest and greatest Intel and AMD CPUs. Ironically, LLVM had a similar fallout in 2010, was committed to unconditionally output multi-byte knobs for all 32 builds. It's like not only 586, 886, you build for 386, you get cursed, hinting, long, undocumented, long knobs because reasons. Someone reported that, however, illegal instruction signal for in Gen G type building CC2 on 586 to a FreeBSD mailing list, and in 2012 Clang crashes on Geode. So much to nobody's using this anymore, right? So after the first bug report, right, knob data uses long knobs unconditionally was filed upstream to LVM. Later then in 2012 committed adding Geode. That's also ridiculous, right? Sometimes, and the code quality of LVM is really not that outstanding. And that is also one point, like instead of fixing it properly, they added, you can't, kid you not, a Geode CPU target that didn't use multi-byte knobs. Like, who is doing that? You do this for 686 and later it's like, who is adding a freaking Geode? Like, did they really do this? Let's click on this. Does it still load? When creating pass the CPU string as well, do they really do Geode? That is what the wiki is like. It's like, if I need another job. God have mercy. What profession have I chosen? Like, use LLVM, they said it's higher quality. The quality. If CPU equals Geode, then open code write 90 hex. It's like why? It hurts. It hurts from, no. It's like, who conditionalizes this on Geode? Not on 586, not on 686. I have no words. It is so sad it hurts. No, just no. But it is exactly that kind of code quality that I'm still working on today, fixing things on MIPS and Spark. In 2014, it was committed to flat out avoid using multi-byte knobs on 686. 586 and avoid on 686, 586 and specific non-Intel CPUs that didn't support multi. Let's see what they've done there. patch added to test, check that the CPU name guess is known, also generate x86 class. The x86 class that don't have VRC3 transmitter, Crusoe, C, as a proof. So what do they do now? Did they do x86 or not? Maybe they really disabled it for everything, which is really silly. So if any of those, it's also still open coded, like do, like you would normally do some Boolean and you're like who is comparing this over and over again? It's like who is each time you write a NOP checking a dozen of strings? Does it not hurt? It hurts me seeing that from here, a decade later. It still hurts. It's like, you check this once, set a member variable of const bool to long NOP. But what do I know? It's... Anyway, do they do x86 even? They even compare x86. I don't know, maybe they left. I mean, yeah, which yeah, is the right thing, but it's like, whatever. I wonder if all the other CPUs support 66 hex 32 prefix override with like AMD. Maybe someone should have tested this, maybe someone did. Anyway, emulators of course had similar things, both QEMU, VirtualBox, like Duo here, and adding hintable knobs of Pentium Pro and 2 was committed to PC emulator. Here to DOSBox X and whatever Intel. Conclusion, Intel's documentation only applies to Intel CPUs. Developers don't really question retroactively additions to instruction sets to some x86, 686 is Pentium Pro, to other 686 is like to sane people, 686 is a baseline variant of very 32-bit, like other reasonable features that were actually documented. It's like, I have... Anyway, if you want all this fixed, including, I tested this of course, I test booted this is x86 kernel, not only on GeodeLX, but also on VIA Asia 2, CNS CHA001 prototype, as a 32-bit kernel today. So this makes T2 the only Linux distribution in decades to correctly handle that, correctly as defined by myself, aka the sane, reasonable, and documented way, and making the most use of all available hardware features, including long NOP when it is available on your Intel and clone CPUs that have that. If that breaks a 15-year-old version of Microsoft's virtual PC, I could not care less. Don't use T2 on broken virtualization software. I'm surely there's an upgrade path for that, like QEMU, PC emulator, PCM, DOSBox, or any of the others. I enjoy my vintage and retro hardware at their fullest and highest performance and appreciate and run x86 class software, including conditional moves, timestamp counter, and long knobs were available on my vintage and retro hardware. And so can you. Don't delay, download, and maybe donate to T2 Linux today, because somehow nobody else really cares, and just, yeah. Anyway, don't tell the Linux kernel developers, bet the risk, because the risk is high that they will just delete it like they usually do, including our Itanium. Of course, if you still have an Itanium or MIPS or PS3, don't delay, because we double down on Itanium support here for you playing along at home on your EPIC and explicit parallel Intel hardware. First question says it could be used for struct alignment, not struct, as struct are data, right? We talk code, so it can be used for code, jump, branch, targets, alignment for potentially increased performance, plus alternative patching. The main use in Linux kernel is actually alternative patching, those code sequences to dynamically just-in-time code generate for SMP versus non-SMP, whether you boot on a single multi-processor or multi-threaded, multi-symmetrical multi-processor system. And other such alternative things. There are a couple of more of such patches. Patent lawyers are ironically anti-patents, anti-IP, like, yeah, probably not those who get the most money. Would know if relates to the Cyrix and what sort of opcodes they used in their CPUs. Cyrix, later Cyrix supports this only the very first, like obviously as soon as VIA realized this back in the day, only early VRC3 are affected, later is not. Just don't, like, yeah, just like comment there, just don't use virtual PC. Like the right response would have been, I mean, beside it was already shitty implemented and disabled not to use x86 on those CPUs. But aside from that, which is now fixed in T2 finally, once and for all. But obviously the right thing would be to implement it correctly and tell Microsoft virtual PC customers, go call the Microsoft hotline and get a fixed update for your broken, or like just run 586 release in your, like if your virtual PC thing is broken, then run bloody 586 build on, like why limit all the other hardware users when it's just one, among other things. So much to the undocumented Intel CPU instructions, right? A decade not implemented, and obviously Microsoft didn't got this NDA note. So yeah, differences CPUs and family. Does NOPL run faster than regular NOP? Well, yes, because if you add multiple, they take multiple, depending on the CPU and instructions and micro code optimizations. A long NOP is one instructions, so you're only wasting decode bandwidth, like memory, cache and stuff, memory and cache bandwidth. So you're only wasting bandwidth, and so with that instruction decode bandwidth, but as long as your instruction decode can fetch that data or has it cached or whatnot or buffered, then long NOPs are faster because it's one instruction in contrast to multiple. Although, as you see there are alternative AMD improved or AMD suggested sequences of 6.6 32-bit prefix. I wonder, by the way, if those 6.6 prefixes, I wonder if anybody, maybe we should test. I mean, I don't really, I have more important things to do. I would hope that someone would have tested this innocent looking AMD suggestion that I would think has a high chance, but your mileage may vary and what's not tested is broken. Where is the 66? Here of AMD recommended 66 32 prefix to 90 hex NOP. I wonder if that works on the alternative CPU clone vendors. Maybe I should test. I have not verified that. Which obviously, I also wonder why everything is so fixated on the Intel implementation. When, I mean, maybe I wonder then if this works on Intel, and maybe it doesn't, but I would think it could, but complex. The complex method is Intel 686, x86. What more do we have there? And then we call it a day. So Lars, ask me anything, last questions first. Great you support. So people appreciate that we support so many platforms. I mean, it's just x86, but I also want, like, obviously when I think a transmitter cruise was 686, I mean, it's 586 plus all this other stuff, and I want to boot my own high performance Linux, and it's also, it's like, yeah, it doesn't, even to this day, it would not work on mainline Linux, right? So, and I don't also want to build a 586, which obviously 586 would also be easily 20% on average slower. And I already built 36 build combinations, right? I built 486. I would build 386, but Linus Torvalds has removed it. So we still build 486. Yes, we could restore it, but we have better things to do. So the reason 486 is the lowest currently supportable thing, again, I would with pleasure do 386, but Linux kernel developers have other plans. And I'm not also building 586, right? I just recently added 686, which is still, I mean, this is why personally for my microkernel, I did everything. Also, yes, performance overhead and whatnot, but that's the thing. We don't JIT, so we statically precompile, and then we have least common denominator of not highest performance, right? And our 686 is already a compromise because that does not even use MMX 3D Now or SSE, right? So you could even have like 786 or 686 plus, but that's the thing, right? You have some CPUs with MMX, some CPUs with 3D Now, then others later with SSE. Yes, for those eventually you can use a 64-bit kernel. That is why in general I think the statically precompiled stuff is somewhat not the most scalable, because hey, I built 36 combinations, but there is a limit. And that is why at least I want better performance than 486, right? And the Linux kernel didn't give me that until yesterday. K62 not supporting NOPL, but being marketed to support it might explain being crashing. Is K6, actually I have a latest, did I add this already? I believe I added, let's check. So the problem is, all those, so all those recent uploads here for my CPU collection are pointless because the Linux kernel had this force disabled, right? So I basically need to re-upload all my own CPU collection stuff here. Which board was it in? That was probably in the Gigabyte board of either this, so that is K63, yeah, this is 5. This doesn't have CMove? This does apparently not even have CMove, so that is clearly not, so yeah, this would not help with it, right? So that's, but you don't need long knobs in it. Surprisingly, it has complex change it. But yeah, you need, so this does not have CMove, but probably, so where do I have, was it that one or that one? Where is my 500? Did I not upload that? How much cache is this? Cache size 550. I'm not sure. Cache size 60. But it looks, because I have a K63. Did I not upload that? Do I have other? I don't think I have other boards. Maybe I've not updated that. Anyway, I mean, we could Google that, AMD K63 Plus, but maybe they were all, here, CPU wiki chip. Where is the CPU ID? Ah, yeah, let's just give me the CPU ID. Do we not have a CPU ID here? Usually they have some. Why do they not have a CPU ID for this one? What is it? Family. But maybe they are all 5 then. CPU world? Ah, this is another side. Ah, then it's this side. Okay, sorry. Yeah, 5D0. So that is also 5. That most likely does not have, it's just die shrunk and whatnot, right? So it's, yeah, that's true, 586. I can't help you with it. It's LVM, what did you expect? Well, everyone else tells me you're not using LVM Clang and stuff, and like, you use LVM Clang. I mean, I'm one of the few who says, have you actually looked at the code quality? Because it's actually for decades not the most outstanding, not even today with the new code, right? And, as we're currently seeing here is our LVM Clang enablement. So one last thing. What else? Can we scroll here? String comparison. Okay, there was sufficient code to complicate string and hash comparison. I have a question. What should I do if I delete the etc directory on Ubuntu? Restore your backup or reinstall or reconstruct it from another machine. Open an Oracle support ticket and good luck. Yeah. When will, Jimbo ask, when will T2 work on 386 again? Not really, because the Linux kernel is, I mean, we could have restarted with that old 3 whatever kernel, but it is pointless to me to, they move so much code around here, as you see just with the history with this common boot file here, that it's a complete waste of time trying to adapt this. We are already busy enough with more important things like Itanium and SGO2 and certainly P3. And 386 is obviously, I mean, 486 is too slow for usable stuff. Even the Crusoe, if not the, I mean, the Geode Elixir is probably a little bit faster, but I mean, it's not like you can browse the internet with, I mean, even with Internet Explorer 6, it was freaking slow on Windows XP on the OCO 01 back in the day, and that was Internet Explorer 6, right? So it's not like you run Firefox on a modern website on Crusoe. You can use VI with syntax, Vim or NeoVim or Emacs or stuff with syntax highlighting though. So I will, with my educational research microkernel, however, support 386 because we can write and dynamically support PAE, physical address extension. Like I also totally hate that the Linux kernel has hard-coded options for supporting PAE and high mem and stuff like this. If you wanted to, could be done dynamically, but so I rather implement such dynamically supporting code and 386 and JIT this, right? Like, because if we JIT most of the code except some generically optimized JIT code, bootstrap code, then we could support 386 and on the fly compile for other things. But that is for another day. Jimmy says just use the latest kernel that still supports the last kernel. Yeah, but this is pretty old, right? This was 3.1 or 3.2 or whatnot of that sort, right? It's, yeah, but maybe you can't even use glibc anymore, I don't know. I had a blog post here, 2017, maybe shortly before my YouTube stuff. So Spark, ancient Spark, do I not have that here? Where is it? Just in vintage. Where is, this is somehow not the right blog post I wanted. Why do I not find my own freaking blog post? Google, hello? Here, removed, here somewhere. Minimal Linux kernel versions. 3.8. So, okay, it was a little bit of, I guesstimated 3.1 or 3.2, it was 3.8. But it's ancient, right? And so also maybe you need then maybe for 386 due to atomics or whatnot, maybe you need then glibc with Linux threads or whatnot. But yeah. Anyway, other stuff. So nodes to serve glibc to 12 to 13. Not sure why yeah, there's also other MIP stuff, and yeah, this kind of stuff is raising then in the minimum required. I probably wanted in 2017 boot an SGI Octane on a newer system, and that didn't have a new kernel or whatnot. And then also documented that this was removed with, wait. Okay, this is glibc. Right, maybe you can't run native POSIX Linux threads glibc on 386. Also, maybe. At least also not for Spark 32 Sun4C, for that matter. So that's it for this video. There are the last comments, and then we call it a day. I hope you enjoyed this and learned something. Links in graphic mode on the terminal, yeah, but that's also not the super most experience, right? What else did you use? So according to online disassembler, according to an online disassembler, 68690 is Exchange x86. Whatever. Links to recollect now, being a while. Yeah, I never enjoyed this browsing the internet with text browser experience too much, and probably a decade later it probably works less than ever due to all the graphically laden and JavaScripted stuff. Got a strange question. Old MIPS machine was currently running OpenWRT. Is this harder to compile T2 compared to OpenWRT? I find T2 easier. The problem with this sounds like a router, right? The only problem is that many of the things require custom kernels, so maybe we don't have the custom patches, and OpenWRT also at times removes this, right? Because 4 and 8 megabyte machines or whatnot, or 60 megabyte, not deemed support worthy anymore. So chances are, if you have a very old thing, it's also removed in OpenWRT. So that's it then for this video. I hope you enjoyed this, learned something. Absolutely crazy state of cursed, patented, top secret, long hinting NOP implementations. But all is fixed in T2 now, so that is certainly the last Linux distribution you will ever need. Maybe go give it a try. Don't forget to share, like, subscribe, maybe Patreon. And have a good day. Maybe go fix some stuff. Certainly there's a lot out there that could be better. And see you soon for all the next fun stuff and fixes and patches to come.